Hello again, and here we have part 5 of eliminations, and this is kind of builds into a review of substitutions and elimination reactions. In the first one, can we draw an E1 mechanism, and do we remember what happens in an E1 mechanism? And in an E1 mechanism, if we were to draw a generic mechanism, we know all we need to have happen is we need to have the best case, a tertiary leaving group. We need to have a weak nucleophile, weak base, and it's best if we have heat. So in an E1 mechanism, the leaving group leaves, we form our cation, and then water grabs the hydrogen on the adjacent carbon to form the double bond, giving us our product. In the E2 mechanism, remember, we need to have a good leaving group and a strong base. And for an E2, it can be primary, secondary, or tertiary. So for the leaving group, so all that happens is our base comes, grabs the hydrogen, we form the double bond, and we kick out the leaving group all in one step, and we get the isobutylene. So in an E2, remember, it happens all at once. The E1, you have to form the cation. It's very important to remember those. So then down at the bottom part of the page, there are two mechanisms. One of them, the second one, is an easy one. We know how to draw it. The first one is one to make us think about what's going to happen as we go on from here. So between the alkene and the acidic water, hydronium ion, which one is the nucleophile? Which one is the electrophile? We all remember that something with a positive charge has to be the electrophile, so that makes the alkene the nucleophile. So the nucleophile is going to go attack hydrogen on our acidic water. Let's draw all the hydrogens out so we can keep track of them. But the double bonds attacks the hydrogen, abstracting one hydrogen off of it. That's going to give us the choice of either putting the hydrogen on the end and putting the cation on the more substituted, or the other possible compound. And we all know that the more substituted the cation, the more stable it is, so we want to go for that. So once we're here, then we see a hydrogen on the adjacent carbon that we can migrate over to form a more stable cation. And then water can add to that cation to give us our protonated alcohol, of which water can remove the extra hydrogen, giving us our product. In the second one, if we draw out the acidic water, we know we have to protonate the alcohol because it is not a good leaving group. Then the leaving group leaves, forming the cation, and then our hydrogen can be abstracted off with water to form the alkene for our desired product. So here we have two mechanisms. We see in both of them we have the same starting halide. The only difference is one has a small base, one has a very large base. So the difference between the two is just in the size of the bases and what can happen. So with the large base, we have to think about what kind of hydrogens we have. And we have two methyls next to the carbon with the bromine and one CH2, where in both of them, actually, it's not just in the one with the big base. But with the big base, it's going to be much easier for it to grab one of these hydrogens on the outside to form the product, whereas with the small base, it's going to prefer to form the hydrogen, or grab the hydrogen off of the more substituted carbon to form the most stable alkene, which is the most substituted. So the size of the base helps us decide what can happen in the overall reaction. So here we have on page 3 of part 5 2 mechanisms, and then page 4 has 2 more mechanisms, the other 2 for the 4 mechanisms we have to know for this section. The first one is an SN1, so in an SN1 we know we go through a cation, and then the I minus adds to the cation to give us our product. So the first step of the reaction is the rate determining step. We form the cation, and then we go over a smaller peak down to our product, and we have this. So on our second transition state, we know that we have the bond between the iodide and the carbon is forming, and we have a partial negative on the iodide and a partial positive on the carbon. So this is transition state number 2. For transition state number 1, we have basically the same thing happening, but it's the bond breaking between the carbon and the chlorine. So it's going to look more like a negative on the chlorine, a partial positive on the carbon. It'll look more like that. Okay, and that's the SN1 mechanism, and we should all know it quite well. The next one is an E2. We have a strong base. Strong base is going to grab the hydrogen, form the double bond, kick out the leaving group all in one step. So our reaction profile diagram will be one peak with, whoops, got an extra line there, sorry. And so we have our starting material, we have our product. Our transition state is going to be where we have our base grabbing a hydrogen, breaking the hydrogen-carbon bond, forming the carbon-carbon double bond, and the chlorine leaving. So we have this for our transition state, where we have a partial negative on the oxygen and a partial negative on the chlorine. All the carbons are neutral. So we're forming a bond between our oxygen and our hydrogen here. I'll dot in more with red. We're forming a bond here. We're breaking this bond between the hydrogen and the carbon. We're forming a carbon-carbon double bond, and then we're breaking the carbon-chlorine bond. And all of that is happening in that transition state. The next page, we have the SN2 mechanism, where the iodide comes in, kicks off the chlorine all in one step. So the reaction profile diagram is a lot like the E2. And our transition state is just where we have the iodide coming in, forming a bond to the carbon with the chlorine leaving. The iodide has a partial negative, the chlorine has a partial negative, and that's what our transition state for that one will look like. And then the last mechanism, the E1, which is the last one you have to know, the leaving group leaves, we form the cation, and then from that cation, our methanol comes in and grabs the hydrogen to form our product. So the reaction profile diagram will look a lot like the SN1, where we have our starting material, we have our product, we have at our transition state the cation, or at our intermediate, excuse me, the cation, our transition state number 2, The transition state for number 2 for this is where the oxygen is grabbing the hydrogen off of our carbon. So we're forming the bond between the oxygen and the hydrogen. We're breaking the bond between the hydrogen and this carbon. And then we're forming the double bond between the two carbons. So we have a partial positive out on the oxygen and a partial positive on this carbon here, and then everything else is neutral. Now, transition state number 1 is exactly the same as what we had in the last, in the SN1, where we have the bond between the carbon and the chlorine lengthening out, where you have a partial negative on the chlorine and a partial positive on the carbon. And this is what our transition state number 1 looks like. So here we ask you again to draw a generic E1 and an E2 mechanism. I want you to draw them, and feel free to send me an email with a picture of what you draw on that, and we can talk about it as after you try it. And if you're not sure about what to do, look back in the videos about what has to happen in an E1 and what has to happen in an E2.